1, 2, 3, да? Слышите меня? 1, 2. Один. Один. 1, 2, 3.
Good morning. Welcome to China. You're at the ICPC Challenge Championship powered by Huawei.
We are facing huge challenges, just waiting to be solved by rest of us.
The business of helping people prosper, for there to be enough and more than enough.
AI community.
I think I need to be very lucky for this.
But in general, I'm quite happy with the trip because it's very nice and very well organized.
I think I will get into the top 10 because I get the top 10 in the previous content.
So congratulations on taking on the challenge and doing such a wonderful job of solving the problems that have been presented to you and everyone on the globe because of the digital age that we live in. So thank you very, very much.
Hello everyone and welcome to the ICPC Challenge powered by Huawei. I'm Tomáš Černý, I'm the Director of ICPC Global Information Services and also the ICPC Challenge Director. And I would like to congratulate you all for making it here to the beautiful Astana in Kazakhstan. I would like to thank the ICPC Challenge team where we collaborate with Code Forces, we collaborate with Huawei on this industry-like problem experience. In the next few hours, you will be working on an optimization problem and the best will earn an invitation to the ICPC Challenge Championship in Shenzhen, China. For your information, this takes place in October. So the second you win, you want to connect with Huawei so that we can arrange your visa. So get tuned because this is an outstanding award that comes apart from other awards that have already been announced. All right, I bet you all are ready to start and getting excited about the challenge. Is that right? I didn't hear you. All right, what are we competing for? We are competing for a great trip to Shenzhen, China for the ICPC Challenge Championship and many other awards. You know, before we start, I would like to recognize a couple of outstanding peers today. And you know, you might be here as well. So how would you feel to be the winner? I cannot say I didn't win, but I have someone who won the ICPC 2023 online challenge. And it is no one else than Daniel Bonot-Rousselet. Please come on stage and I will introduce you a little bit. So Daniel holds the PhD in computer science from École Normale Supérieure Lyon, France. He has been a standout in recreational and competitive programming since 2017. He currently holds the first place in optimization category at the Coding Games platform. His achievement in the ICPC online challenge only reflects the value of this competition, which provides a great platform for the ICPC community to engage with emerging technologies through innovative problem solving. And I will ask him something. Daniel, how did the ICPC online challenge influence you once you became the champion?
Thank you. Well, I could tell you that since I won this challenge, people stop me in the street when I go buy bread and groceries. I think you wouldn't believe me, right? So I don't know about you. Why do you compete in this kind of programming challenges? For me, mostly it's because it's interesting, because of the thrill. And I'll make you a confidence is that actually for me the highlight of that competition was not when I won. I was very happy to win. But it was when because actually you need to know the background. It's an optimization challenge. It lasts for 2 weeks, so you have time to work on it. It was actually when the last day I decided I have 24 hours left. I'm going to rewrite everything. And just because I have a new idea and I thought maybe that will bring something. And when it did, and it actually jumped not to the first place straight, but that was really a great feeling. It was probably one of the best feelings I had doing competitions. And so winning was a bonus, but that was the great joy. Something I want to mention about this competition is that I did win it using the Rust programming language. Are there Rust lovers in the room? Yeah, I see a few, and I think in the future there will be more. So if you use something else, that's great, but I want to encourage you that it's possible to win with Rust, and I think it helped me to have a correct program. The compiler helps you. And then, yeah, that's, if you want to talk about Rust and know how you can use it in competition, I'm happy to talk. And I think I want to thank ICPC and Huawei for organizing this kind of competition, for Huawei to being a big supporter of competitive programming and to make very interesting problems. So thank you and good luck to all of you today.
Thank you, Daniel, and please stay here because we will have another person to invite, but I have a personal message, ad hoc message. You know, typically when you get the Best Paper Award or something like that, they ask you to organize the next conference, right? So we would welcome you to help us to prepare those challenges, and I think that you can spread that trust, interest to get that great idea to the others. So we would be very happy to work with you as well if you are interested. But I have another very interesting person to recognize today. And if you were at the CLI symposium yesterday, you might got the message, right? The message is that we do not have many women here. Do you agree? Wow, maybe we should do some special outreach. And I have a special guest that maybe could help us a little bit. So, as we noticed, this gender disbalance, we have an outstanding momentum going on in Aisha Amritapuri regional contest that was initiated by Mashehwarara Chaitanaya in 2022. I really apologize for mispronouncing your name. You are entitled to mispronounce my name as well. And due to this effort, there is over 4,000 participants from all around the world in the ICPC Algo Queen. It's a girls programming cup, and today we have the Algo Queen winner. Ladies and gentlemen, we have Nino Shinzake, please on the stage. I will introduce you a little bit and we will also give you a space. So she started programming in the 5th grade. Yes, in the 5th grade at the computer school in Missouri. And since then she excelled in numerous informatics and mathematical Olympiads. She earned 1 bronze medal, 2 silver medals at the European Girls Olympiad in informatics, 2 bronze medals at the International Zhukotov Olympiad in computer science, a silver medal at the Baltic Olympiad of Informatics 2024. And now we have her here to inspire more women. So I will give you also a question, right? And this is a hard question, and I know that answer could be a little bit difficult. So because you are the woman, you probably can tell us a little more about your story. How can we improve? and what can we do in order to attract more women to the competitive programming?
Yeah, thank you. Hi, everyone. First of all, I'm very happy to be here. And I want to say a huge thank you to ICPC Foundation and Algorithmic for giving me the opportunity to be here and inviting me at the ICPC World Finals. And I'm very excited to be at this event. And as for my question, I think it's important that I first share a bit about my experience in competitive programming. So I have represented my country, Georgia, at the European Girls Olympiad in Informatics, EGOI, 3 times. This year, it was my final participation at EGOI and final attempt to go onto the high school level Olympiads. And it just so happened that on the Georgian EGOI team, there were only 2 participants. Instead of the possible 4, we were only 2 participants. And the main reason why that happened is because there's very few girls interested in programming in Georgia. And this is a problem that the girls are underrepresented in programming, and that's an issue not just for Georgia, it's a global challenge. And there's a lot that needs to be done about this. So in my experience, I started participating in the Informatics Olympiads at an early age. So in 5th grade, I learned my first programming language, which was Pascal. Then I moved on to C++. And yeah, then I started participating in a lot of competitive programming contests. So around the time when I was in 7th grade, I had participated in a lot of informatics Olympiads, but I was also struggling a lot with maintaining my motivation. And as a girl, being involved in programming, it's much harder to be confident and to stay motivated all the time. And what helped me significantly throughout this period was the competitions that were aimed at girls and that were aimed at encouraging them in programming. And the ones that I would highlight are EGOI, European Girls Olympiad in Informatics, and Algorithmic, the Girls Programming Cup. So these opportunities were incredibly motivating, and they were a huge motivational boost for me, and also they helped a lot with my confidence over the years. And I would say that they played a huge role in me being on the path towards becoming a woman computer scientist. And there should definitely be a lot more and more of those kinds of opportunities out there for girls, such as contests, competitions, coding camps, hackathons, and events that are aimed at advancing girls in competitive programming and just in general in computer science. Because such opportunities have played a huge role in my journey in programming, and I think that if we have more and more of those opportunities, we will definitely reach a lot more girls and help them in their journey. And they will become interested, the women will become interested in such events, like in this field, at a very early age, and such opportunities will help them to stay motivated over the years. So thank you, and hopefully we will see many more girls on the programming competition.
To the ICPC challenge here, and it's our industry partner Huawei. So everyone, I would like to give a round of applause to Huawei partner for supporting this event today. I specifically would like to recognize 4 authors of today's challenge, which you are about to experience. So it's Li Wei Song, Mingyu Deng, Alan Abrahamov, Abdelhan Muratov. So thank you, and if I can get one more round, please. All right, I think I have been speaking quite long, so it's time for me to invite the Huawei representative on stage and share a little bit about their mission and what they are presenting here today. So I would like to introduce one of the authors, the first one, Li Wei Song. And he's an expert at the Huawei Cloud Computing leadership in the Algorithm Innovation Lab. So if I have you here, please come on stage.
Thanks for the introduction and good morning everyone. So I'm Li Wei from Huawei Cloud. This is actually my first attempt to attend the ICPC World Final activity. So I feel so honored to have such opportunity to share with you guys about the practical algorithm problems we face in our company. Just one more recap of the whole team. So besides me, we have Mingyu, Alan, and Adi. So of these three, they have the background either on the ICPC or on the MOMC contest. So a lot of you guys may already interact with them yesterday in the Huawei booth. So throughout today, throughout the challenge, we will be together with you again for the problems. Also, we have issues, so if you have any questions, just feel free to reach us. So this is our lab, which is called the Algorithmic Innovation Lab. It was established in 2019. So the focus of the lab is for the mathematical modeling and the algorithm solving in the cloud computing area. So we are actually strongly engaged with the ICPC activity, including the online challenge problem, including the training camp. Also across these years, we have received a lot of awards when we finished the project, when we solved problems. So in the right, we have the most recent one, which is the Franz Edelman Award finalist last year. So this award is for the application award, which is the most highest from the optimization theory, when the optimization theory can be applied in the industry to have the broad impacts. Okay, so I have few slides to talk about the big pictures of Huawei Cloud. This is the first one. You can see a lot of numbers. I'm not going to talk about those numbers. So instead, I just want to emphasize the three important things. In the middle, which is we call infrastructure as a service. So because cloud computing is proposed for the customers' easier usability. So for the infrastructure, we actually want, like every customer, they can access the cloud with easy use. On the left, we have the second one, which is called the technology as a service. For the technology, it's like more about when we design the system, when we design the algorithm, and when we have some fantastic ideas, we want to deploy such ideas quickly to have the broad impact in the industry. So that's why we have the technology as a service. On the rightmost, we have the expertise as a service. It's more about like when we finish the project, when we achieve some success in the process, we want to reuse such success, such expertise to better shape the cloud computing area. So coming closer to recent years, I think everyone knows that AI is changing everything in the society. So that's also the case in Huawei Cloud. So towards the AI-oriented applications, this is the rough structure of Huawei Cloud. So in the middle, you can see we have a series of Pangu models, which can support a lot of diverse applications, including government, including finance, including airport and others. So to support the Pangu series models, we actually built the distributed infrastructure and architectures to better train the large language models and to better do the inference job of the language models. So to give a quick summary of these slides, we actually want to combine both the infrastructure redefinition and the product refactorization together to support that we reshape the whole cloud computing industry with the AI technology. Okay, so these slides are just the big pictures of the company. So in the next few slides, I actually want to show some examples of my personal feelings after these years in the industry. So the first one is about the algorithm challenge or the algorithm difficulties when we study the problem, when we try to solve the problems in cloud computing. The core part is what we call multi-tenants. It's very special component in cloud computing because for cloud computing, like everyone, they access the cloud. And naturally, we have multiple users. So in the very beginning, you can just imagine the cloud computing as a super huge computer. And so all the customers of us, we want to access it. So we just have to compete with each other. But at the same time, like all users, we don't want to be disturbed by others. And also, like you can imagine several users, we will send the request at the same time. So that's the reason why we introduce the virtual machines, why we use containers to better isolate different jobs from different users. But that's not enough because we have more and more users. They will request more and more resources. So we have to design the scheduling or design the whole system to better support the customer experience. Nowadays, like for the ChatGPT similar applications, there are a lot of the requests for such activities. So that also brings today's challenging problem, which I will describe later. So here are two concrete examples in the past projects we deal with. So in the left, it's the traditional virtual machine computing allocation scenario, where we have the request. So in the leftmost, which we called the pod. So in the cloud, we have the nodes, which are equipped with CPU and memory and other stuffs. So the easiest way to understand the problem is that once a new job comes in, we have to find a space to allocate them. And when they finished, we also have to design the algorithm to delete it. Of course, like sometimes when the current machines, when the current equipment don't satisfy all the potential need of the customers, we have to create more machines to support the request. So this is the first example. On the right part, this is our network bandwidth allocation scenario. It's actually for the live streaming service in Huawei Cloud. So the diagram, it shows that how we can transmit the content from the broadcaster to the audience. So in the right picture, in the left, it's the broadcaster, and in the rightmost, it's the audience. So what we need to do is we have to transfer content from the leftmost to the rightmost across multiple layers. Those layers can be the cached nodes or just some relay nodes. So at each layer, we have to decide like which node we have to use and how to allocate the total bandwidth. The goal is to, first of all, we want the easy access. We want the latency of the live streaming to be as low as possible. And the second most is we want to keep a moderate pricing, keep a moderate cost of the whole system. We don't want to use a lot of money to waste so much money. So that's the idea for the second one. So in this slide, I actually want to show another different example. So the last one is the problem we face. So this one is actually how we solve the problem by using the example of the medium network scheduling system. So here, again, two examples about the algorithms. So the left one is for the root path search. It's mainly designed to reduce the latency of the live streaming service. So you can imagine that in the medium network, we want the latency to be quick. Therefore, in the very beginning, it's the shortest path selection algorithm, naturally, which is simple. But in practice, we have to consider all potential failures of each cached node and each traffic link. So that's the reason why we bring the top K shortest path search selection algorithm. Also, in some cases, we want such K disjoint paths because all potential failures, we have to have some backup plans. So this is the example of the root path selection algorithm. On the right, we have the traffic flow allocation, which is designed to how to allocate each user's request to which part of the node and which part of the traffic link. So naturally, it's a multi-tier architecture, and we simplified the version into different granularity. So in principle, the idea is the multi-modality flow problem. And we design a lot of the advanced network flow algorithm together to build such system, such scheduling system, which leads to the Franz Edelman Award finalist I just mentioned earlier. Okay, so this is the last part, which is exactly about today's challenge problem. So I think you already see from the description, the challenge problem is about the large language models. It's not about how we make the model more expertise in dealing with the language task. Instead, we are dealing about the infrastructure to better support the training efficiency of the large language models. We want to shorten the training time of the model training. So in Huawei Cloud, we have such service, which is called Ascend AI Cloud Service. It supports diverse language model types, including our own Pangu models, also some open source models like Llama, GLM, Stable Diffusion, and a lot of others. So the goal for today's challenge is for the efficiency. So I will just go to my last slide. It's more about the detailed background of the problem. So in the leftmost, we have the training methodology of large language models, which we call distributed and parallel training. Why we need that? Because large language models, they are super huge. They contain hundreds of parameters, and they use much more training samples, much more training tokens to feed the model. We don't have such big GPU to feed all the parameters, all the data into one card. So we instead use thousands of, or tens of thousands, or even hundreds of thousands of the AI cards to support the training. So we have to split the model parameters and also the training samples across different GPU cards, across different GPU or NPU cards to support the training. So there are three typical parallelization mechanisms, which are called data parallel, pipeline parallel. So from the name, data parallel is to split the data across different MPO cards. So when they do the back propagation, those cards, they have to share their back propagation gradients to average and for the further training. But only for data splitting, it's not enough. We also have to split the model weights. That's why we have the tensor and the pipeline parallelization. So these two, they somehow like divide the model weights in a different way. So we can imagine the language model as a series of the matrix multiplication in mathematics, because they do a lot of matrix multiplication. So for the tensor parallelization, we actually split every matrix into different parts and share among the AI cards. So that's tensor parallel. So for the pipeline, what we do is we group the, because we have a lot of matrices in large language model. So we actually group such parameters into different subgroups. And now we assign each subgroup to one card. So the behavior between these two, and also including the data parallelization, is totally different. And nowadays, every company, including Huawei Cloud, including others, they do the large language model training using the combined 3D parallelization, or even more further, 4D or 5D or 6D. But for today's problem, I will just talk about the basic 3 parallelization mechanism. So this is the methodology for the distributed training of the language model. On the other hand, we have to allocate the resource to support the distributed training. So this is a structure to show the assigned AI cluster in Huawei Cloud. In the bottom, the rank ID is just some logical numbers. Those numbers are important because in the left, the distributed parallel, it just decides like which logical numbers, they form a group, they share their gradients, they share their tensor matrix, and how they will communicate with each other. Those are decided by the logical rank IDs. So the story will be we have to map the rank ID one by one to the AI card. So now the MPO cards, they will communicate with each other by certain rules during the training process. And how they communicate is based on the topology of the cluster. So we have the MPO, we have the several MPO together, we form a server, and several servers together, we have the cabinet, and more cabinets together, we form the whole cluster. So for the communication, if at the top switch, which is above the MPO cards, so if the traffic goes to that way, and I will just use the sender and the receiver to make it easy. So if the sender and the receiver, they are under the same top switch, they will just finish at this level. Otherwise, they will move up further to the span switch to have the communication. So that's the basic background of the challenge problem. So the way why this is important is that because of the distributed training, we actually have a lot of communication behavior among these AI cards. So if not carefully designed, we can imagine a lot of the data values, a lot of the traffic flows, they will collude with each other in the network path. When a collision happens, it means the delay of the communication, which means you have to spend more time to train your large language model. More time means more money, means more waste of your wealthy in the production. So that's why we bring this problem today to the ICPC challenge. Okay, yeah, this is my last slide. So I wish you all have best of luck today. Thank you.
Thank you. And before you leave, I would like to take a picture with you.
Sure.
Are you up to it?
Yeah.
Thank you. Here we go. All right. We are back and we are about to start. Someone wanted me to give a signal for the coaches to get ready, but as I was walking through the contest floor, I have seen that some of you were meditating, you were kind of mindful preparation, so on. And some of you were sleeping. So, can I get everyone up and stand up? Yay! And do one step back and do a little squat. I'm getting you ready. It's for your own good, guys. You want to get it, wake up. Oh, wow, that guy's doing push-ups. Yeah, way to go. I see some underdog here and some yoga. Awesome. Very good. Get back seated. I'm ready. I'm ready. I hope you're ready as well. And I have learned that there were some few late arrivals, those that were missing badges. So we will give you the last chance to join your team and join your station now. So please come here to rejoin your team or rejoin your station, and please remember tomorrow you will stay outside. All right, before we start, I have last few instructions, and those instructions were given to me by the ICPC Technical Director, John Clevenger, the guy that will be presenting here tomorrow. So in an emergency, the contestants will exit through the yellow door on my right, on your left. The spectators will exit through the center back door and the door to my left. So that way and that way. There will be marshals to direct you in an event of emergency, which is extremely unlikely, but we want to be ready for it, so please follow their instructions. As I said at the beginning, but since we had a couple of you rejoining, I have to repeat myself, which we don't want to do in your programs. The bathroom is over there, where you see that blue segment, someone was just entering in. So this is for the contestants. You are not allowed to leave the contest floor. For the spectators, the bathrooms are in the lobby. Box lunches have been distributed, so you have them in front of you. In any case, there will be something missing, please reach out to one of the marshals and we will make it solved. Finally, it's against the rules for the teams to attempt to connect to any other computer on the network. Please keep in mind that we don't have internet for the challenge, so the only way that you can connect is to go to the code forces as you will be instructed. All right, do I see anyone to give me a thumb up that we are ready to start? I see a thumb up. Yay, I see all the thumbs up from the teams here, even from the main guy who is running the infrastructure here. All right, so I hope that we are ready for the coaches there as well to distribute the problem sets. So do we do a countdown? 3, 2, 1, go!
All right, we are here at the 48th annual ICPC World Finals in Astana. Right now, we are running the ICPC Challenge, which is sponsored by Huawei. And this is a 3-hour contest that all of the teams are participating in. So, yeah. Do you want to talk a little bit about the challenge, or is that up to me?
I think that's up to you, but we recently had a first submission.
Yeah, we just had our first submission come in, and it is from the Australian National University. So the submission came in roughly, what, 15 to 20 minutes into the contest. So this contest only has one problem, but it's a 3-hour contest. So teams will obviously have some time to, make submissions and try to score points. So for those who are not familiar with the ICPC challenge, it's a little bit different from maybe your standard like Code Forces contest or AtCoder contest or ICPC contest. So in those contests, usually you're given like a very strict, well-defined problem, and you're told you need to compute like this exact value, like compute the minimum like possible penalty you can get, or like compute the maximum possible score you can get, or compute the number of ways you can do some process. And in those problems, there is a binary, like this program printed the correct answer, this program printed the incorrect answer, and you only are considered to have solved the problem if you pass all of the test cases and you print out the correct answer for all of them. This ICPC challenge is a little bit different in the problem structure. So there is some similarity. So you will get a problem, and the problem will actually be well-defined. The difference is that the thing that you're trying to compute, there can be it can be evaluated on a not on a binary scale, like it's correct or it's incorrect, but you can sort of score it based on like the quality of the result. For example, maybe the problem is like, oh, you want to find the shortest path in a graph, but you have some constraints, and maybe you can't actually compute like the shortest possible path efficiently. But if you output like a path that's maybe a little bit longer, even though it's not like the shortest possible path, you can still get partial credit for it. And so that's kind of what's happening here in the ICPC challenge. So there's a single problem, and we'll go over the problem in a little bit, but these contestants, they have to write a program, and they have to try to compute like the best possible answer that they can, and the better their answer, the higher their score will be. And so that's how the evaluation is done. So it's not going to be who scored or who solved the problem first, because the problem probably cannot be solved in like a 0 or 1 sort of fashion, but the contestants will just be graded on the quality of their submissions, and then whoever has the highest quality submission by the end will be crowned the winner of the ICPC challenge. So
currently you have 2 teams that submitted tasks.
Yeah, so we just had the second university. I believe this is the Universidad Federal de Minas Gerais. I don't actually speak any languages besides English, really, so my apologies if I'm butchering your university name. But we can see that they had a submission at the 20-minute mark, and their submission got just over 326 points, which is not as many points as the submission from the Australian National University. So they're currently in second place. Oh, we just have another submission coming in from Tsinghua University. It looks like it got just over 400, if I'm reading that correctly. So they're now in first place. Now, these teams will have multiple chances to make submissions to the problem. So some teams might have the strategy of hiding their submission until the last minute. And that's a potentially high risk, high reward strategy. It's high risk because if you only make one submission and you have a small bug, then you get 0 and you don't get anything. But if you submit really late and you get like a high score, then teams might not be able to match that score at the last minute. So like if a team comes in and they score like 2,000 points at like 20 minutes into the contest, and all the teams will be trying to find like a 2,000 point solution, and some team was able to come up with it within 20 minutes, so the other teams have, you know, a couple hours to come up with it. But if you do it at 2 hours and 59 minutes, then I don't think there's any chance of a team being able to make a submission in the last minute to match. So it's definitely high risk.
I think one more important point about ICPC challenge is, if I'm correct, you don't see the test before. So the test information is not open, as opposed to some other alternative competitions. So you have really limited way of knowing your points before you submit.
Yeah, so some of these, some people might be more familiar with this contest in the style of, say, top coder marathon matches or at coder heuristic contests. Those are probably the two most mainstream contests that offer something similar. And so, at least in marathon matches, what would happen is there would be a provisional test set. And so the provisional test set would be some tests that were released, and when you submit your program for evaluation, your program is judged only on the provisional tests, and then you get a provisional score. And then all the teams are sorted by their provisional score, but then at the end of the competition, they will run it on the full tests, and so the provisional tests will be a subset. And so part of the reason for this is if you only have the provisional tests, then maybe what you can do is you can write some heuristics that work very well on the provisional tests, but don't necessarily generalize that well. And so you could get like more points than a solution, a more general solution might, if the distribution of the tests was slightly different. So by withholding some of the tests and then doing the evaluation on the full test set later on, you're basically incentivizing the teams to try not to think too hard about just making heuristics that are optimized for the provisional tests, and thinking a little bit more about how do you make your solution more generalizable so it does better on the hidden data set. I haven't actually looked at the problem description, but I imagine...
Yep, I've read through it lightly. This year's problem is about, of course, the main hot topic, LLMs, and mainly about how do you allocate your data on your servers. So the task is roughly routing the data across 3-layer networks. So the way they work is you have racks. Each rack has a switch. We'll call it T or R. And each rack has multiple servers in it. So the servers in the rack are connected to this central switch in the server rack. But then all the central switches are also connected to splines. Spline is an entity that can connect multiple TOR switches. And what you need to do is you are given multiple flows of data, essentially point A to point B, and you need to calculate the way to route them efficiently. We'll discuss it more in the technical details later, but roughly the main idea behind this task is your speed and latency inside one rack is quite high, and you get additional penalty for going into more hops. But also, you get additional penalty for reusing the same hop. If you use the same hop in multiple connections, your latency will grow. In this task, it grows linearly. In real life, it's probably not that simple, but this is.
Yeah, so I'm trying to look here to see how the scoring works, because I was just spending some time talking about this provisional data set and this hidden data set, and if I'm reading here, I see the sentence here that says when the contest is over, the participants will be ranked according to their quote final score unquote. And then it looks like there actually are no hidden tests for the ICPC challenge, which is perfectly fine. Like in this style of problem, it doesn't. There is no strong restriction that you have to have like a holdout test set or anything like that. Maybe you want that if you want the contestants to try to implement sort of a more generic solution, but in this case, maybe Huawei just wants to know like what is the best that you can do under these circumstances, and so maybe the contestants will come up with some cool heuristics that work on the main test set. One thing to keep in mind is that the contestants do not have direct access, I believe, to the test set. So when they submit their program for evaluation, it will be evaluated on those tests. However, they don't get to actually see the tests directly. They will just get to see sort of the results of their program on the tests. So they get to run it and they'll see the final score, but they won't actually be able to see the exact structure and maybe hand construct heuristics for that.
So I think we're gonna take a pause for now. We're gonna review the statements, and we're gonna return to you back with some more insight on what's happening and probably some ideas of ours.
Yep.
We will still leave the overlay open so you can see the queue and how the participants are solving the tasks. And we'll see you in a minute.
Yep. Okay, welcome back. So we have here the problem statement for the ICPC challenge. We didn't actually copy the title, but I'm sure we can sneak a I can sneak a
The
peek at-
title is Data Transmission Route Planning on AI Clusters.
Yes, data transmission route planning in AI clusters. So even though this is a problem that is has LLM theming, the contestants are not actually, say, implementing an LLM. I'm sure that there were some people who were kind of hoping that the contestants would have to do that, but that's not actually what's happening here.
Not that year.
Yeah. So I'm going to go ahead and sort of slowly read through the statement here. It's pretty dense, but I'm going to try to go through it a little bit slowly, just so we, just so everyone can kind of understand what's going on here. In this problem, the goal is to train an LLM, and one of the problems with training LLMs is you're sending lots of data everywhere, and so we want to alleviate network congestion. As we all know, when your internet's really slow, when you can't watch your favorite Twitch streamer or whatever, life sucks. So gotta alleviate that network congestion. Okay, so in the context of training this LLM, what is going on is we have this like big computing cluster, and so the computing cluster itself is just like some network, and there are 3 layers in this network. So we have what are called neural processing units, and then we have network switches. So here we have this diagram here. And so here are the 3 layers. So at the bottom, we have these neural processing units, the NPUs. And then up here, we have the 2 layers of network switches. So here we have what's called TOR, or top of rack switches. And then the topmost layer are called spine switches. And so you can see here in this diagram that each NPU is connected to exactly 1 top of rack switch, and then each top of rack switch is connected to every spine switch. And so you can see that there are some NPUs that share a top of rack switch, but then there are some NPUs that don't share top of rack switches. So imagine that we want to send data, for example, from NPU 0 here to NPU 1. So what you can do is data can go from NPU 0 up to the top of rack 0 switch, and then the data can go from top of rack 0 switch back down to NPU 1. And so this is the shortest path, and there's literally no reason to send data up to the spine and then back down the spine and then back to the NPU. However, because the top of rack switches are limited in the number of connections that they can have to NPUs, inevitably you will have 2 NPUs that want to communicate, but they don't share a top of rack switch. So let's say that we wanted to send data from NPU 0 to NPU 7. So note that they don't share a top of rack switch. So NPU 0 can connect to top of rack 0, but NPU 7 connects to top of rack 1. So in order for data to go from NPU 0 to NPU 7, we have to pick some spine switch, and so the data will go from NPU 0 to top of rack 0 to some spine. Let's just say it was spine 2 for the sake of this example. Then it goes down to top of rack 1, and then it goes down to NPU 7. So at a very high level, the problem kind of goes like this. We have a bunch of workers that need to communicate data between each other. And so we can assign each worker to one of the NPUs here. So there is a distinction between like worker and NPU. So for example, like here I can have like worker like 3 Whoops, that was very awkward. Can I undo this?
Yep.
Okay, so let's try this. So I can have like worker 3, and I can assign that to NPU 7, and then here I could have like worker like 1, and assign that to NPU 0. And so if worker 1 wants to communicate with worker 3, then it has to go like up the top of rack switch to a spine, down to another top of rack, and then down to the corresponding NPU. Okay, so workers get assigned to NPUs, and then we know that like certain pairs of workers want to communicate with each other. So if 2 workers happen to be connected to the same top of rack switch, then they can communicate directly. So that's what this over here is saying. So yeah, if NPUs of the 2 workers are in the same rack, then data is forwarded through the top of rack switch. Otherwise, you need a spine switch, and the spine switch will be needed to form like this data transmission path, where you go from the NPU to top of rack, up to the spine, down to the top of rack, down to the NPU. So like graphically, like it goes into the top of rack, then you pick like some switch, and you go down the top of rack, and then down here. So that's like the bad path, and then like a good path would be like this, for example, where you don't have to go up a spine. Okay, so how do we sort of score like this assignment? So what happens is, so you can see that there are all of these edges here. So you have edges connecting like the NPUs to top of rack, and then edges connecting top of rack to spines. And then we have a guest behind the scenes over here. Okay. So each edge gets used in some number of connections or communications. Oh, are we pulling in?
Howdy.
Our wild guest appears.
Well, it looks like you guys are making some progress on this. I got to go to a lunch. Isn't that strange? You know. But at any rate.
You got to put in your FaceTime.
Keep after it. Yep.
See you.
For those who aren't in the know, that was Bill Palcher, our executive. What's his title? Executive Director, President of ICPC Foundation. I'm not sure. There's a big camera crew that's off screen just following him. He's a big deal. He's a big deal in ICPC, and obviously he can just come in and interrupt. Well, you shouldn't say interrupt. He can come in and grace us with his presence. Okay. So I was talking about how do we grade sort of like this assignment. So each edge will be used in some number of communications from worker to worker. And so there's like a basic latency that is associated with each step here. And so the total latency in like the simplified example is you just multiply the latency by the number of times the edge is used. Yep. So if you don't use the edge at all, it doesn't matter how slow it is. It doesn't actually affect anything. But the moment you use it once, then you incur like 1 time of the latency. If you use it twice, you can't actually like parallelize it. It's all sequential. So you incur 2 times the latency, and so that's how the latency is evaluated for a single edge. And now, to measure the latency in general, there is some parallelization that can happen. So for example, like this red connection here can sort of happen at the same time as the blue connection because they're not sharing any edges. So the latency of the process in total is just the largest latency incurred on some edge.
Yep. And the important part is latency is assigned per step, not per process or per edge.
Yes. Okay. And so this problem, if this problem sounds like crazy complicated to you, don't worry about it. This is the ICPC World Finals. These contestants have been dealing with like hard problems, so they're used to the difficulty. If this is still taking some time to sink in, don't stress about it. But for the World Finals, they wanted to make it even more challenging, and so there isn't one training task that is running. There are actually 2 training tasks that are running at the same time, and so this makes the latency computation just more complicated. Specifically, what happens is you look at the number of times that the edge is used in both training tasks, and then you just take the maximum over each step, I believe.
Yeah. I think other steps synchronized?
Are the steps synchronized? I think they're not actually synchronized. So tasks repeat their training epochs with different start times and periods, so any combination of steps might occur at the same moment.
Yep. Okay.
And they estimate the worst case separately for each step of each task.
So essentially at each point, there are 2 steps which are running,
Yes.
but the steps are not promised to be like at the same level at each
Yes,
time.
Exactly. And so, okay, so that's like the problem, sort of described it slightly haphazardly, but now we have to talk about how to score it. So basically what happens here is there's sort of a baseline score, and so like the best case is if you sort of like, there's like a theoretical lower bound that you can hit, and if you have the theoretical lower bound, then you get 100%, or you get 100 points for each test case. And then as the latency increases, the score decreases sort of inversely. So if you're like twice the baseline, then you get half the points. If you're 5 times the baseline, you get 1/5 of the points. And so for each test case, you can get up to 100 points. And so we're going to skim over a bunch of the technical details here about input and output. But the sum of all weights is 16. So I believe what this means is the example score, or the maximum possible score that you can get, is 1600.
Yes, that sounds... Yep.
And so I'm going to quickly peek at, I believe these are the standings. And if we make this a little bigger and we refresh it. Okay, so it was a 3-hour contest, and here's the countdown. So we just crossed the 1 hour mark. So there were 2 hours left in the contest. And we can see currently in first place is Belarusian State University with a score of 1,325 points, which is around 85% of the maximum possible score that is attainable, which is pretty impressive. Usually in these tasks, like 100% is not actually like even plausibly attainable. So the actual theoretical maximum is probably much lower. So it's not actually 1600. The actual the theoretically achievable maximum is probably, maybe it's 90%. Maybe it's 1,400 points or so.
Yeah.
So
I think it's like, for this problem, it should be higher because the basic latencies are like quite substantial.
Mm-hmm.
So you probably never see a basic latency. I assume there will be cases when you have to reuse at least some edges.
Mm-hmm.
So probably nobody can ever get to the perfect score, but people will probably get to like a reasonably high score in this.
Mm-hmm. Yeah. If we quickly peek through the scoreboard to see how many teams have actually made submissions, it looks like roughly 60-ish teams have made scoring submissions to this problem.
Yeah, I think so.
And so that is just under half of the teams. But there is still 2 hours of contest to go, so if you don't see your university on the scoreboard, that's perfectly fine. Some teams don't want to submit like a small solution to now get like only 300 points. They're probably gonna they're probably thinking like, how to go big? How do I get like over 1,000 points? And so that's going to be the challenge here. And I think, well, pun maybe intended? I don't know. Anyway.
Yeah.
So yeah, so we still have 2 hours, and hopefully we're gonna be bringing in some guests. We have, I believe, we might have like the challenge like directors on, and then previous ICPC challenge winners I think are also slated to come online.
The important part is also this challenge is both possible to write for teams and for coaches. So we'll have the possibility of seeing 2 different coaches team. So this table is the current coaches that submitted tasks.
Yeah, so we can see here the current top coach is from Columbia University with just over 500 points. And then we can see coaches from a couple other universities.
Yeah.
But yeah, I think we're going to take a quick break, and we're going to try to find a couple guests to join us here on this broadcast.
Yes. See you in a minute. Bye.
Okay, welcome back. So as promised, I have a couple guests with me. If you two could please introduce yourselves.
Hey, I'm Tomasz, and I'm the chair of the ICPC Challenge.
Hello, I'm Christian. I'm actually CLA Symposium co-chair, and I'm looking forward to helping more in the challenge side. Yeah, and then I currently observe in this World Finals.
Yeah. So as you can see, ICPC is powered by many different staff members, and we're all sort of putting on various hats here. Can you talk a little bit about how you became the ICPC Challenge Chair?
Wow, that's a very funny story, right? So the whole story started me in 2006 going to Baylor University, and you probably remember that it was the headquarters of ICPC. And I remember David Stargell running the ICPC challenges back in a time. It was kind of a visualization of robots trying to win some kind of competition, and eventually they invited the industry partners, and that became the new sort of flagship of ICPC to have those challenges. And it's not really bound just to one industry partner, but currently the top partner that we have and that we have a long tradition with is Huawei. And if you remember from a few years ago, if you are within the community, there was Jeff Donahue. He was actually my PhD thesis supervisor. And Jeff Donahue was running for a very long time, but the duty called and he relocated to another university, and I was asked if I would take the role for the position to make some improvements in the process as we do that, so that we could maybe have a larger bandwidth of how many of those problems we can kick off. So I'm still new, I'm still observing, just like Christian said, we both are kind of new, but we're trying to make the impact in the perspective that you are getting the expected sort of competition out of those challenges, and we can provide more and more throughout the year.
So you've been here for quite a while, and so as you say, you're sort of still observing. But how have you seen the challenge evolve, sort of like over the years? So you mentioned like the robots, but like more recently, like have there been any big changes? Or?
Yeah, so when it started, it was really academic thing, right? And if you remember, we also had Quest Challenge, which was really something for the local students in here. And I think that there is a very nice adaptation going to what is happening online with the code forces and what is happening at the top coder, that you kick off a challenge that is a very different type of a problem than what we are solving at the ICPC. So we are looking for some optimization problem, which takes a little bit of a different mindset. And of course, what else than to invite some industry partner to have this practical sort of feeling, right? However, the nice blend as we are evolving is that it's not only us learning from the partner is learning from us as well, because they are really solving industry problems and they are trying to reduce some kind of complexities that they have. So the evolution was really from the academical scientific view into let's go to industry, let's invite the industry partner, let's engage them, let's get something practical, and let's see how the learners, those, well, you know, you are competing, you want to win, but you are still learning, right? Because more of those challenges you do, you are building your karma, you're building your reputation, but you are also getting the sense how it is to be in those big companies. So the evolution is we want to make it as close to the industry as possible. Again, we don't ask you to deploy 3 containers, but we try to reduce it in a perspective of numbers and mathematics.
Yeah, so Christian, I believe, has sort of this blend of like academic experience, industry experience. Like, how do you feel about this sort of like ICPC challenge and sort of how close it is to both like this academic and industry?
Right. So if I were to comment, first of all, I think it's a great initiative and also great program that we have here. The challenge itself, I think, is getting some context that is a little bit different than just the algorithmic challenge, right? It's a bit more of a marathon style, and so it gives you a different flavor of problem that you can actually work together with I guess your two in a team of 3. And so I do expect that, you know, it's a in some sense a different challenge than what the algorithmic problem solving that World Final is doing on Thursday, but it's actually quite interesting of its own. It gives you like a 3 hours of talking to your peers and discuss the problems that are a bit more, let's say, coming from the demand of the industry. So I think the fact that we have both of those things happening at the same time at the sort of 1 week that contestants are actually spending time, I think is a blessing from the participants' perspective, so long as we can actually generate the problems that are genuinely interesting from the sponsor side and also participant side.
Yeah, very cool. So as we know, the ICPC has always been very big on like the algorithmic problem solving, like these very well-defined problems that maybe they don't have good connections to more of like the real-world concepts. Like, do you think that the ICPC challenge format, like, how is it possible to like expand that? Like, is that even possible, or you know?
Yep. So if I can take the lead on this, I would like to highlight that the problem comes from the industry, right? However, the way it works is that they present us a raw problem, and we need to make it in a shape of what the community expects. That's why we partner with Codeforces, right? It's a great platform. We have great people participating on it, and we have very nice talent that is giving a feedback to the industry partner on this is what the expectations are, so that it's easy for whoever is engaged in this to understand that problem, that perspective. So that's the nice collaboration here, and I really see three circles, right? You have ICPC that is leading this, you have Codeforces that is actually hosting this on their platform, but you have the definer of that problem, which is the Huawei. And that blend, that connection that we can provide is to make it really the greatest experience that we have. And being proud of being sponsored by someone who can provide nice awards is the top thing, because yes, you could do a small competition, you are the number one, you are increasing your karma, but it's nice to win something, right?
Yeah, so I guess if I were to add, I would say, this the fact that we are able to come up, work together with the Codeforces, who's great at creating the platform where the problem can be hosted, and the industry where industry sponsor who can actually give us a greatest problem to actually tackle, and ICPC to really bring the greatest participants together. The fact that we can actually collaborate in this sort of three-way is a blessing, I think, and it's really from my perspective as an observer, it's been great to see that that's actually exactly what's happening in the community. So yeah.
Yeah, talking about the community, I think a decent number of people in the community, they like don't have a lot of exposure with like the sort of the challenge format where you have like this more like industry driven problem, and there isn't like a correct answer. It's sort of like you try to get like better and better answers, but no one knows like what the best possible answer is. Do you have anything to say to like these observers who are like watching, and maybe they're envisioning themselves being at the World Finals in future years?
Sure. So again, I will take the lead on this if I can. I think your perspective is what are the challenges of challenges and what is the future of the challenges. And it's important to say that to prepare a challenge takes half a year. And it's a rather intense work, and that's pretty much why we have Christian, because he's going to be instrumental to this process. And we are talking across different time zones, and we have weekly stand-ups to push this forward, right? I want to highlight that that's why we have this community. So the challenge is it takes time. It takes multiple languages to have involved in as well. So, we are using Telegram, we are using WhatsApp, we are using all sorts of mechanisms to make it together, because you have restrictions from different governments. But we want to make it happen, and we want to make it a great experience. And in that perspective, the challenge is we need those experts who are currently ranked very high at Codeforces to actually step in and say, hey, I want to not only be solving those problems but preparing those problems. And trust me, it's a great win, because you suddenly open the chef's lid and you see how these things are happening, right? What is happening on the background? Someone has to write the test, someone has to write the scoring. If you have a great problem, but you would score everyone the same score, that's not how we want it to work. So the next initiative that we have with Christian, we are reaching out here to some famous developers like Tourist or Andrei Lopatin, or the former winner of the ICPC online challenge, and we're like, hey, could you guys help us and give us a feedback, right? Because when the industry sends you a problem, you need to give them a feedback. So is this a suitable problem to run on the optimization for multiple days or not? So we would like to have it kind of a peer-reviewed process. At the same time, we are working with a trust. So if we have those people involved, of course, we assume they are not going to leak the solution, because they were those guys enjoying this competition. So it's their interest to make it more fun. But you know, they can influence the community. So for instance, we were speaking today with the 2023 online ICPC winner, and he says, I'm programming in Rust, and I would love to talk to you if you would like to program in Rust. And I'm like, well, come on, come be on the board and help us prepare those challenges, because then you can have a greater influence on people playing with Rust.
Right.
Christian?
Yeah, so I feel like really the point is, we love the, in some sense, the enthusiasm and, let's say, love coming from the community of competitive programmers. Really do need help to, let's say, bring the challenge into the next, sort of like a charter. And that's why, in some sense, I'm here, to really express the fact that it's actually very exciting. But because it is exciting, we do actually need a lot of help from the community to really bring it together to the next level. And that's why we are really hearing it together. And what I'm hoping is that, by giving this hopeful message, that a lot more people will reach out to, either of us, Tomasz, myself, and also Veronica, who is a sponsor, the director of development, who can help us, streamline this process. And I'm hoping, and very enthusiastic in some sense about this particular engagement, because I think that we can do a lot of greater, expansion and great things together. And if we put more energy from the communities of competitive programmers, I think that it can only go for a more positive direction, moving forward.
Yeah. It looks like we are probably a little bit over time. I know.
Oh, wow.
I know you wanted to keep this to like only 5 to 10 minutes, but we're already over 10 minutes. Just letting you know. Do you have any last words you want to say to our viewers?
I will let you lead, and then
Oh, sure. So basically, like a TRDR, people say, or summarize, please come help us. We need your help. And that's why I'm here standing. And I'm, quite hopeful and enthusiastic that we can turn this, into more positive direction and more exciting for everyone, especially in the ICPC community and also perhaps any other competitive programming community out there. So.
I would like to add 80-20 rule. So try to compete on 80% of your time and try to contribute 20% of your time. Serving on the panel is actually going to help you, because you see how we are thinking when we are rating the problem. So when you do the next challenge where you are not preparing it, you will know what sort of the preparer was thinking, and you can optimize the score. I also would like to reach out to you guys, because you don't need to be afraid to reach out to us. Code Forces, reach out to Mike, reach out to whoever is in charge. They will get connected with us. We are partners on this. And if I can say one message, and I'm sorry, it's probably going to be my brand now, I would like more women in this perspective, right? So don't take it in a view that, oh, we need to give a special price. No, just do the outreach. Like, what can we do? What can we, let's say, adapt to make it attractive for them, right? So maybe having a woman leader on the review board would help us, because she could be the inspiration for the others. So I don't want to take it from the, hey, we give a special award for them. No, we just want to help them, because when we bring them, we will innovate, right? And innovation from 51% of the population that is not currently involved in this is just something that we are losing the point.
Yeah, definitely agree with all these points. Well, thank you again for coming on stream, and it was I know it was a little bit harrowing to get everything all set up and so on, but I'm glad that we got to hear from both of you. We're going to take a quick break, and then we'll be back with more content from the ICPC Challenge.
Thanks, Nick.
Thank you.
Okay, welcome back to the ICPC challenge. It's been a few minutes, but we have a couple guests here, and I believe that these two are part of the group that was responsible for coming up with the problem for this Huawei challenge. So could the two of you introduce yourselves?
Hello, my name is Alan. I'm working Huawei in St. Petersburg currently. And yes, you're right, we were in the group that worked on the problem for this competition, for this challenge.
Okay, hello everyone. I'm Deng Mingyu from Huawei Cloud Algorithm Innovation Cup, and I'm one of the author of the problem.
Cool. So thanks for joining us on the stream. I'm sure there are people here who are curious to hear about, what it takes to come up with a problem. So is that something that the two of you can expand a little bit on?
Sure. Let's start.
Actually, the problem comes from some real problems of the company, and maybe it's about 1 year ago, and we start to think of how to deploy such a large system on the computing cluster, and that's a very complex problem. And it is about how we arrange those computing resources like GPUs, or we call NPUs. Actually they are different, but it doesn't matter. And how we build up all the network between them, and how we deploy a large language model among those resources, how they parallelize, how they work together. And there are many problems here. So there are they need many people to cooperate to do with it, and different teams may focus on different aspects of this problem. And what I'm focusing is about the network, the network part, how they transmit data from to each other, and how they do it efficiently. That's the point.
Okay. So this problem, just as a reminder for our viewers, this problem was about minimizing network latency. And so this is a real problem that Huawei is facing. So when you were actually solving this problem in your job, did you know that it was going to be like a future ICPC challenge problem?
At some point, yeah. So it was introduced that, initially we didn't start with that, but then there are several problems that are expected to be present for such kind of challenges, and this problem was one of the good choices that can fit the challenge.
It is a very good choice to put it in some kind of contest, maybe not ICPC or something other things, because Huawei has many competition. Huawei holds or sponsors many competition that we have many chance to put it out and let all the people work together to try to solve it. So at the very beginning, we thought this is a very good question. Some days we will definitely make it into a contest problem.
What makes a problem like a good problem for Huawei to put in like this style of contest?
The first thing to concern is definitely about if we solve the problem, how will it change all the things? How will it benefit the system? How will it benefit how do we use it to achieve our goal? That is the most important thing. And the second thing is about can we make it in a mathematical form? How can we build out a model? If we can't explain it clearly, then I think it's not a good question for the contest.
I think. Have you finished? Yeah, I think that just on the other side of the coin, because there are some very beautiful, nice problems that not fit the contest style, I think. So there are some set of iterations, like maybe initial problem is a little bit not as good for a contest or for such kind of challenge, but then after several iterations, you become it more fitting with the contest style, rules, and so on. So at least, for example, you don't need to there are different contests, like some of them have a like very long time for solving, like maybe 1 week. Some of them are like much shorter, like this one, like 3 hours. So that a lot of details that you trying to optimize to make it more suitable for such kind of events.
Yeah, that makes a lot of sense. Like, I think if I don't know how much experience you two have with like the more algorithmic style of contests, if you were former competitors or so on, but yeah, it's nice to have a strict mathematical model for these problems, so that it's easy to kind of reason about, and so that having the nice structure just makes it like easier to think about. So you mentioned that both of you, well, you two both work at Huawei, and you helped offer this problem. What sort of balance is there between like your day-to-day job in terms of working on these problems versus, or working on like preparing the problem for a contest versus, say, you actually need to try to solve it like for your job at Huawei?
You can start then, or okay. That's bound. So that depends on the time, for example, because on the initial step you mostly focused on the problem itself, not as a problem for the contest, not related to preparing. But after some time, so there are guidelines from ICPC side or any organizer that's working on that. So currently it was ICPC side, and you like trying to follow this schedule to prepare. So that could vary. Like at some points you need to focus more on the problem, like on developing the problem, on making the statement, or making some tests and so on. At some point you mostly focused on other like duties for a job related to this problem, not so. I would say that there's a good balancing, and you also can work with that by yourself, like handling that, saying to your manager that you need to like spend some time. So it was at least you had some time that was given to you to work with that problem, to make it like good for challenge.
Yes, actually the result of the contest also benefits all the works. So if we are planning to prepare for such a contest, they will have like take half of the time to prepare for it, to just write the statement and refine it like that. And after that, we just analyze all the solutions, and we will get a very good idea, and that makes sense.
And I would also add that there's some kind of sort of synergy. Like when you're working on that, I wouldn't split it into two different parts of work, because still you can get some idea from working as a contest problem. You can then try it in your real problem or otherwise. So it's like very cool. And sometimes not obvious connections that could arise.
Mm-hmm. So talking about like actual ideas here, I know we had some viewers who kind of want to know like how to solve this problem. I don't know if you have any like how much you're able to share, but if you had any sort of anything you wanted to talk about in terms of like how to approach like this specific problem or anything like that.
Mm-hmm. Any hints? Any comments from you?
Actually, the testers, some of the testers get more score than all of the contestants now. That is, actually, this point, the statement contains many message information in it, and some of them are critic, but some of them are just about a large bit of waste, like that, and some they may make you confused or where I should start with, something like that. If you get the right direction, maybe you will soon get a very high score, and that is about what we actually do in real life, because when we face on a very complex problem, there will be useless information in it, and I can say most of the information is useless in it. So how can we find the critical points of it? That is the I think that is the point to the high score.
I can add that some of the testers get less points than the current maximum. So, as you said that you just need to try. So there, of course, there will be not good ideas. There will be some good ideas. So you just keep trying, and then.
And actually, the score doesn't mean any all the things, because the model is simplified many times, and to use it in a real problem, you still have to do some modification, and that is the value of idea. So we'll just check the answers and find if there can any ideas we can use. So that is more important than what we how much score we actually reached. But that is not for a contest. It's for the real problems.
Right. Like I think I understand what you're saying. Like in the real problem, you have this very simplified model for latency, and in the real world, latency is not just like number of usages times some scaling factor or whatever. Like it's obviously more complicated than that.
Yes, in such a big system, it is a weird thing that everything runs in their place. That is weird. It is common that many of the things are running in a strange way, but it actually works.
Yeah. So I'm going to try to wrap us up here for this interview. I wanted to thank you again. Were there any final words that you wanted to say to the contestants who will watch this later on, or to our viewers right now?
Good luck for finals.
Yeah, that's important. Yeah, and also enjoy these finals, these events. We'll try to make as much as possible to make it enjoyable from our side, and I hope that I want to say thank you to organizers, to participants, so on, because it's done a great work to do that, so I hope that everyone will enjoy that.
Yeah, it's definitely been, this is I think the second, maybe third day for contestants here. And so, we're just getting them warmed up for the finals, which will be in 2 days, and that's what everyone's sort of looking forward to, that final competition. But I wanted to thank you for helping to make the ICPC challenge possible. And we're going to go ahead and take another break here on stream. So we'll see you in a bit.
Bye-bye.
I don't think it's... we are back. So tomorrow and Thursday will be the dress rehearsal and the actual World Finals.
Yep.
And so I quickly wanted to pull this person next to me on stream. I'm sure most of you know who he is, but for those who haven't, can you introduce yourself?
Hey, I'm Eknerwala. Or Andrew. I'm going to be commentating tomorrow. I'm excited to see what the teams are going to do in the actual contest. But first, we're here in the ICPC challenge, right? And this is a challenge run by Huawei, right?
Yeah.
And it's a bit of a different contest. There's one big problem that has no deterministic or guaranteed solution, and it's all about trying to pick the right heuristics to make it as good as possible in the real world cases.
Yeah, and that's definitely the sort of problem that outside of the context of programming contests, you might have to do. You don't know what's optimal, but maybe you don't actually need the optimal solution. Once it's good enough, you can just ship it, and then you can move on to the next problem.
Right. Yeah.
Yeah.
So how far are we into this contest? How much time is left still?
Yeah, so in terms of the amount of time we have left, I think we're coming in on the last half hour or so. I'm seeing, just over half an hour left in this 3-hour contest. And so these teams have been hard at work.
Right.
We can see right now, if we look at the scoreboard,
right.
The top team is currently the University of Tokyo. Their best submission came in at the 2-hour and 10-minute mark, so that was roughly 15 minutes ago.
Right.
But if we look here at these submission times, there were lots of teams that are hard at work. Like St. Petersburg State had a submission just 2 minutes ago,
right.
and they're in second place.
Yeah.
Belarusian State is still in third, but their best submission was just actually in the first hour of the contest.
It's interesting.
Yeah, we can confirm that they're hard at work. They have been making submissions. Their most recent submission got somewhere around 1,100 points, which is not their best submission. So as a reminder, in this format, it's not the last submission that counts. You just take the best over all of the submissions.
Right.
So that's why Belarusian State, even though their last submission was not as good, that's why their score hasn't gone down.
Right. Yeah. And one interesting thing, so I was looking at the problem a little bit ago. So the way this problem is scored, you're trying to there's some graph and you want to route some flow through the graph, and you're trying to minimize the maximum amount of flow through any edge. And optimal obviously is each edge only supports one flow. And that would be optimal. And the way that it's scored is roughly there's 16 test cases. In each test case, you get 100 times 1 over the maximum flow you get that you use. Kind of. With there's some weighting inside and things like that. But the main point is that an optimal solution would get 1,600 points because that would mean that would mean that you actually are using only exactly 1 flow through every single edge. And so we actually see the top teams are at 1,400 points or 1,300 points. So they're actually getting pretty close to that. And then, so a score of 800 corresponds to using 2 flow at most. And so, that's kind of a way to interpret how these scores are working. So the top teams now are trying to optimize it so that in more of the sub cases more of the sub cases are optimal. They actually have most of it already completely optimal, but maybe some particular interactions are not.
Yeah, so one interesting thing about this scoreboard, if we actually look in detail, so first and second place are unique, but third place right now, there are actually 3 schools with exactly the same score. So Belarusian State, as we mentioned, but also Kyoto University and then Pohang University of Science and Technology. So how could these 3 teams have exactly the same score?
Yeah, it's really interesting. I'm really not quite sure. So these scores are all I was thinking about the problem a little bit, and so these scores are all a little bit higher than I would I think you could tie on, but I think there are some deterministic solutions that would achieve like 800 or like 600 points or something. So maybe they all implemented the same like kind of deterministic solution. The scoring is pretty like it is pretty pretty discrete because as we were saying, like either you have an edge with 2flow or you don't have an edge with 2flow, and so I guess they must just have some pretty similar approaches that actually have very similar that actually have very similar sets of like which cases they find hard. It is pretty surprising.
So I think we have just crossed the half-hour mark. And so I'm wondering here, I don't think this is a case in the ICPC challenge, but in other contests, we have this thing called a scoreboard freeze.
Yeah.
So yeah, you can see right now on stream, it's 2 hours and 30 minutes and 39 seconds. So I don't think the scoreboard is frozen here, but let's say the scoreboard were frozen. Like, how would that, firstly, how would that look to the contestants, and then how might that affect like the rest of the contest?
Yeah, so in the last hour of a ICPC style contest, the scoreboard is frozen, and what that means is that you can see what submissions every team does, but you can't see the verdicts. So it's actually there is like some bit of gaming because yeah, so you actually don't know exactly what the scores of all the other teams are, so you don't exactly know how many problems you have to solve. You do see your own submission results, so you do know if you like need to keep working on a problem or if you've already finished it. There is some games you can play, like it is actually possible to keep submitting to a problem after you've already solved it, after you've already gotten a correct solution, and that actually would show up to other teams as just additional submissions. So you can kind of hide whether you've successfully solved a problem or not, if that's something you want to hide. But it's not there's not too much reason to play those games.
Yeah, if anything, like you might get some negative feedback from your competitors where they're like, oh, I see that you have 40 attempts on problem A,
right.
And why did you submit 40 times on problem A? And then if you just look at them like coyly and you're just like, oh, I don't know, we just kept trying stuff, but they got it right on the first try, then you know.
Yeah, and I mean, I think the scores are actually the scores actually aren't revealed all the way until the closing ceremony. But people talk, and so the suspense on that front is a little bit like it gets broken a little bit. I think sometimes coaches can see what they solve, and teams obviously know themselves. So the secrecy there it's kind of nice, but it gets leaked pretty easily.
Yeah. So yep, last half hour of the challenge. So let's say that you actually were doing the challenge. I know you like looked at the problem briefly and you thought about it a little bit, but like strategically, like how does working on one problem for 3 hours, like how might you approach that?
Yeah, I mean, I think the main thing is like it's probably good to kind of start just writing out some prototypes early on, and once you have these prototypes, then you can start working harder on just trying to figure out exactly which pieces are working and which pieces aren't, and like kind of refine your point of view there. And I think I don't think there's too much more than that. I think if you have 3 hours, you get to try a lot of different things, right? You get to kind of take your initial idea, and you have these teams are working in their full ICPC team, and so they get to pick. They get to come up with maybe separate ideas and kind of try implementing many of them, and kind of try a lot of different things and try and figure out which approaches work the best. Because really they don't know which approaches work well until they get some results.
Yeah, one thing that is definitely different about the challenge versus the more traditional style of contest is here there's only one problem.
Right.
And so as we all know, you only have one keyboard.
Right.
So in theory, you have this issue where there are many things you could type, and you don't have multiple people who can type multiple ideas in parallel. But usually what will end up happening is you probably converge on like one idea, and so you'll like by like the 2.5 hour mark, like teams will probably have decided like this is how we're going to try to do the problem, and then you don't actually need to worry about any sort of keyboard management. Whereas in the last hour of an ICPC contest, you might have people who are working on 2 different problems, and then you have to decide which one do you commit to.
Right. Yeah. There's definitely a lot more like working on. Everyone's working on the same problem, so you're kind of all working on the same code base. Yeah. I'm just looking at the scores. Looks like there hasn't been too many changes. Definitely a lot of teams are actually submitting and getting lower scores than their previous scores, which makes sense. It's hard to evaluate, and some experiments work and some experiments don't. But yeah.
Yeah, I wonder like what these teams like, how these teams actually think about approaching like these sorts of contests, because this style of contest is not nearly as common as like your normal ICPC contest. And so have teams practice this format? Probably not. So it'll be interesting to see sort of like, they're probably also just trying a bunch of ideas and seeing like what gets them higher scores and what doesn't. But the progress is definitely, I would say, a lot more like, it's not very linear in a sense. So like, for example, like Belarusian State got to this 3rd place in under an hour. And then the other 2 universities, Kyoto took 1 hour, and then Pohang took 2 hours. And so, other teams definitely have that potential to get there. And actually, that might lead to some interesting results. Like, do they tie break by time? Or
they must tie break by time of submission, right? Well, that's what the scoreboard shows right now. Maybe they don't tie break. I'm not really sure about that.
It is a little unclear, because I think on our view of the ranks, it says that they're all like 3rd place.
Yeah. So maybe they are maybe there's no tiebreaker set, and it's actually we'll just have 3 3rd place teams or even more.
Yeah. Can have the famed sort of 13th place bronze medal. Have multiple teams in 3rd place.
Yeah, and one other thing I've seen is like, if you look at these team submissions, that they've actually still been submitting after they achieved their 1325 score. And like all 3 of them have had like more than 10 more submissions after they've achieved the score, and haven't really been able to improve it. So it's pretty interesting that they all came to the same approach or something, and then are kind of like, it really is like a bit of a local optimum that like they can't really push fast.
Yeah, and then like if we contrast that with like the University of Tokyo, like they actually never got to this 1325 score. So they were at 1295 right before the 2 hour mark, and then right afterwards they jumped up to 1372, and then they were 1411 for a while, and they recently just jumped up to 1414. So they're actually able to squeeze out like these like very small improvements here and there.
Which kind of means that like their approach might have more room to grow, and might have more like directions you can optimize, which is pretty interesting.
So definitely this goes into this whole sort of like local optimum thing. So teams will have ideas, and then each idea sort of has its own like theoretical max for where it caps out at. And maybe this idea that like these 3 teams have, like it's very easy to get, but it does not scale any further. So they're just stuck, and they have to come up with something completely new. And so that's why like Tokyo didn't hit that. There was just an announcement which says that for prize distribution, if 2 teams have the same exact score, the tiebreaker is a time of submission. So actually, there is a tiebreaker. There is a tiebreaker by time.
And that'll be Belarusian State that wins the tiebreaker there.
We can see also that St. Petersburg State also did not hit this 1325 score. They were at, it looks like 1264 at the 2 hour mark. And then they jumped passed 1325, they got 1328.
Yeah.
And now they're at 1359 and maybe trying to squeeze out some improvements. But
Yeah.
they're probably solidly in second unless some other team can come up with with whatever novel idea Tokyo and St. Petersburg State have.
Yeah, yeah.
I actually think it might be possible for us to
to actually look at the
we
code.
can actually peek at the code and we can kind of see, like, if we really wanted to, like, what are these teams doing. I don't know if we want to do that. That's
well, it looks like these teams are one interesting thing is glancing at this code, I don't really see simulated annealing. Do you see any simulated annealing?
I do not see any simulated annealing whatsoever.
Which is kind of interesting, right? There is RAND, but it looks pretty deterministic.
Yeah, I see. This is all deterministic. Is this used? Is this code used at all?
I don't know. But it also looks deterministic.
Yeah, they just solve. There's like a. So we're looking at the Tokyo team's code right now, and we don't see anything that is like deterministic or based on seed.
Yeah. So it seems like they are just like using some kind of fixed heuristics, and they don't. It's not like it's not something which is very easy to like iteratively improve on.
Yeah, and then if we look at St. Petersburg State.
Yeah.
Well, we do see round.
Yeah.
But do they actually use it?
I don't really see any shuffle or anything. Oh, there's a clock.
There's a clock.
This looks like it could be
there's
simulated.
There's clock, and then there's some round.
Okay.
So they definitely have something that
maybe
might
some hill
look like
climbing or something. Yeah.
Yeah, they definitely have. They're definitely like iterating. They're just like trying to do something.
Yeah.
And then actually we can also just peek at these three teams, see if they have conceptually the same idea.
I would expect if they all achieve the same score, then they probably do not have any like randomization, because that would be very unlikely that you can converge on the same.
So we see some gray code. So gray code is actually not surprising to be used here, and
interesting.
It looks like they do some assignment just based on gray code. Is that what I'm seeing?
Maybe, yeah.
Yeah, I see assignment based on gray code.
Right.
We're gonna peek at Kyoto and Pohang.
Oh, actually, Kyoto.
Oh, Kyoto just
jumped up to 1326, and also Pohang actually did as well.
Oh,
so
wow.
Belarusian State is actually now the only team that's still at this 1325 mark.
Yeah. So.
Oh, they're actually not even at. They actually improved their solution too. That's not the same number.
It is 0.5 higher.
Yeah.
Or.
Yeah.
Yes.
0.5 higher.
0.5 higher.
Yeah.
So these teams have all managed to push past.
Yeah.
And so now there actually is apparently now there's actually a race to see who can squeeze the most out. So
right.
This contest just got a little bit more interesting.
Yeah. Interesting. I'm curious if the code looks very different. So maybe let's look at this submission, which is their new high score, which
see a shuffle.
Yeah, and their old high score might look more similar to the one we expected before. This one, oh, the code doesn't look that different. It looks much longer. So probably they had to implement kind of a whole new like subroutine in order to get this like extra boost.
Yeah. So yeah, this is usually what I think we kind of expect from the ICPC challenge. It's each of these teams has implemented some like simulated annealing or hill climbing or beam search or something to try to search the space, and then they just have to they have to either come up with like good heuristics to squeeze out a better score, or you know, in the worst case they change their magic seed to maybe be a little bit better.
Right. Interesting. Yeah, but it looks like, yeah, there's 15 minutes left in the contest, so teams probably can't start whole new approaches, but they definitely can like keep refining their approaches and keep running things, changing their seed maybe.
Yeah. One slightly interesting thing that I'm just noticing from the scoreboard and in comparison to like maybe different previous years is that so this contest is not just open to the contestants. We also allow the coaches to compete. And so there are some years where the coaches will be like competitive or actually just straight up winning the challenge. This year, it seems not quite like that. It seems like in the top 20 participants overall, we only have one coach who has done it. That's not to say that, the coaches are like.
Yeah. Well, it's kind of a matter of like, it depends a lot on some of the coaches may like may not care, or some coaches may have other things to do. It's all the teams are in here, but the coaches could it's like optional for the coaches, and also kind of it is the teams are like a team of three. They do have more ideas to come up with, and they have kind of just more people to tackle the problem with. So
yeah, that's probably actually a real good point. Like, this isn't necessarily a contest of who can like write the code the fastest or who has like the best like algorithmic problem solving, but it's just who like you have 3 people, you have 3 times the ideas maybe.
Right.
And so if you're just generating tons of ideas, then maybe with 3 people it's easier to come up with that good idea that really pushes your score up. I'm trying to look here at the tail end to see. Hopefully all the teams have like been able to score some points. We were checking at like the 1 hour mark. But yeah. I see we actually have a guest that wants to join the broadcast. So let's take a quick break and get our guest set up. And we'll be back with another interview.
Yep.
All right, welcome back to the ICPC Challenge. I have been asked to introduce myself because I've been talking for a long time on this stream and no one knows who I am, and that's not good. So my name is Nick. I will be one of the commentators with Andrew at the ICPC World Finals dress rehearsal and the real contest tomorrow and Thursday. Some of you might know my handle on Codeforces as Showocone. Call me that, call me Cone, call me Nick, whatever works. But yeah, that's what the one means in case any of you didn't know. So we have another guest here with us. Could you introduce yourself, please?
So, hi everyone, I'm Nino from Georgia, Georgia the country. And yeah, I was invited to come to the ICPC World Finals as a guest because I won like Algo Queen Girls Programming Cup. And yeah, it was a very nice prize to come here. And actually I'm 18, so I'm still too young to participate on the ICPC because I'm not a university student yet. But yeah, it's a fun experience being here.
That's really cool. I actually was laughing when you said Georgia, the country, and not this and
not a lot of people know.
Yeah, so I feel like I need to explain this because I imagine a lot of our viewers actually have no idea what this means. So if you look up Georgia, like Georgia definitely exists as a country. However, if you go to the United States, there is a state called Georgia. And so frequently what happens is in the US, when they talk about Georgia, people will be like, why are they talking about Georgia like not in the, like it doesn't sound like the Georgia that's in the United States. It's like Georgia somewhere in Europe or Asia somewhere like. Yeah. And so, yeah, Americans, like, they know their state geography. They know Georgia's a state, but they don't know that Georgia's a country. Yeah. So it's very funny to hear the reverse, to say that, like, oh, yeah, Georgia's a country, not the state. But, yeah, so you mentioned that you won the Algo Queen contest, and this was your prize to attend the World Finals. Is this your first time attending, like, an event of this scale, this size?
Well, like, I've participated in a lot of informatics Olympiads, so I've been to European Girls Olympiad in informatics, but yeah, definitely ICPC is the largest Olympiad that I've been at, yeah, World Finals.
How would you compare EGOI to the ICPC just in terms of like the two events? Like what are there like any big differences between the two that you've observed so far?
The one that I would say, game rooms. We had a lot of game rooms on the European Girls Olympiad, but I don't see them here. And also, like, I realized that there's like, I don't know, less than 5 women on the team.
Yeah.
That is kind of surprising, actually.
Yeah, like I haven't been to EGOI, so I don't actually know like the exact event. Obviously, like EGOI, the contestant distribution is going to be drastically different from like the ICPC. Like I think ICPC is probably like 95%, if not more, male. I think on the volunteering side, it's definitely a lot better. I think like we definitely have quite a lot. And so you mentioned that you're not yet in university, so. Whoa, something's happening in the back. Oh, they did a 5-minute announcement for the challenge, and it just echoed for us. So you mentioned you're not eligible for ICPC yet because you're not in university. Do you see yourself doing ICPC like as well?
Yeah, sure. So this year, since I'm on a gap year, I'm like applying to universities in the US, where like I will study computer science and artificial intelligence. And yeah, I definitely want to come back to the World Finals in a participant role other than a guest. And yeah, I think I see myself coming back here actually.
Yeah. The North American ICPC scene is something that I'm familiar with. I help out a lot in the ICPC there. So yeah, it'll be great to have you as a contestant, and maybe I'll see you in the North America Championship because that's where all the top North American teams go to compete. And the North America Championship is a little bit, they try to make it like the World Finals, but just sort of like for North America. Yeah. And so the scale it's a little bit different, but hopefully it is, it'll still be like as fun of an event. Yeah, how did you get into informatics in the first place?
Yeah, so like I got into programming in 5th grade. So in Georgia we have like actually this I guess computer school. It's called Missouri, and there's where a lot of students who are interested in math competition, like from a young age, and there are a lot of them, I guess. And like this is a computer school that we go, I guess, after like having fun with the math competitions, and then we started learning programming, and well, naturally, math competition turned into programming competitions. And yeah, and also I have 2 older brothers, and they were doing the informatics Olympiads, so I was like naturally interested too. And yeah, I went to that computer school. I started learning C++, and I liked coding, so I continued doing that.
That's great to hear. Yeah, like that's starting really early. Like 5th grade is pretty early as far as I know. Like I can tell you that I personally didn't start until like 9th grade or so on. So it's cool that it's getting introduced at like a younger and younger age, and it's super accessible. And then you just are informatics competitions like the part that you enjoy the most about computer science, or are you more interested in like the theory, like the AI and so on?
I would say maybe both. But yeah, in the university, I plan to kind of focus more on the like AI stuff, and maybe less of competitive programming. But even on the gap year, I'm planning on taking still courses contest and yeah, participating as if I'm still a high school participant.
Yeah, and if you really enjoy like informatics competitions and you want to keep doing it, like ICPC is the natural next step for university students. So you can, if you go to a university in the US or anywhere else really, like I'm sure that there will be like a club for ICPC, and then if that's something that you still want to do, like it'll be easy to kind of invest more time into that and to help make ICPC like be sort of part of your like informatics experience if that's something that you want.
Definitely,
yeah. I'm looking here at the contest. It looks like we have just under 1 minute. So we're probably going to we're gonna probably wrap up the stream really shortly. But I wanted to sort of give you the opportunity to say like any last words you have for like any of our viewers or like the contestants or anyone else.
Yeah, I mean, for like high school Olympiad participants, I think they should all continue this competitive programming journey and definitely imagine themselves like at the ICPC World Finals. And yeah, like just continue taking contests so that we can also come back here to the World Finals as participants.
Yep. It sounds like the contest is ending right about now, so I think we're gonna stop our broadcast for the challenge here. The teams are gonna be coming out shortly, and we'll see what we're going to present later. I hear we might be presenting day 2 of the CLI Symposium, featuring some prominent competitive programmers like Gennady and I think Andrei Stankovic, and I forget who else. But yeah, thanks everyone for tuning in, and we will see you tomorrow at dress rehearsal.
This will ensure that your material will be there tomorrow for your dress rehearsal. Here are a few reminders. You want to wear your t-shirt tomorrow. And if you want to wear a hoodie because it's cold, or light jacket, it should be worn under your t-shirt. And you think this is cold, I was told that in Astana they get up to -50 Celsius in the winter. So it's not cold yet. To check in, tomorrow you want to be at the team staging area, and you must have all of your members of your team with you. Also, please have your badge that shows your name and it's your identifier. not bring any food, drinks or electronic devices into the dress rehearsal tomorrow. You want to leave all your bags, computers, cell phones with your coaches tomorrow. And if you have no coaches at the team staging area, there will be a backdrop inside that. No coaches will be allowed at the team staging area tomorrow. And when you line up for the procession, 3 members of your team need to be together. Remember, you may not add anything else to your team materials tomorrow. I have a couple of more updates, and one is related to the bus schedule for tomorrow and also for the World Finals. So please listen carefully now. One more time, I see someone not paying attention. If you miss it, this might have a bad consequences, so please listen carefully. The bus schedule has been revised for Hilton Garden, Saad, and Solux. The first bus will now depart at 8 a.m. and the last bus will depart at 8:15 a.m. Sharp. If you miss it, you miss it. For Wyndham Garden, the first bus now departs at 8:15 and the last bus will depart at 8:30 a.m. It's crucial that you arrive on time. If you miss the last bus, you will be late for the team check-in at the expo, which is a mandatory event. We want to make sure that everyone has a smooth experience, so please be ready and be in your hotel lobbies with your team shirts, badges on, rather in advance. We also understand that some hotels have experienced delay with the elevators in the morning, so take it into an account. And many of you experience the traffic. All team members must board to the bus together. You will have the opportunity, apart from this, to enjoy an excursion today. It is excursion of Nul Alem Future Energy Museum, the big star, that star bench that is nearby. It's approximately 10-minute walk from here, and it is at the 8th floor. It has very nice interactive activities, so if you like to attend, now look at your badge or look at the number of your team, because we have different timing for this excursion. So if you are team number 1 till number 33, so I believe I would be looking at this stage, your check-in time is at 3 p.m. for that museum. If you are team 34 till 70, your check-in time is at 4 p.m. If you are team 71 till 104, your check-in is at 5 p.m. And finally, if your team number is 105, all the way up to 142, your check-in is at 6 p.m. If you want to check in change the time slot, you can try to come to the lobby at any of those 4 time slots and you can be added to the wait list. If there is a no-show, you will have the opportunity to come in at a different time. If your team needs their photo done, please, because you were late or some arrival, they will be taken in the lobby at 5:30. And that's all for today. Thank you for the wonderful competition, and I cannot wait to announce the awards tomorrow.